Let us summarize interference and the critical points that are important in YDAC setup. The first point that we take up as a part of summary: suppose we have amplitudes of waves arriving at point P on the screen are different, then the resultant intensity at the point of interest will be equal to, that is I will be equal to I1 plus I2 plus twice under root I1 I2 cos delta. Also the maximum value will be under root I1 plus under root I2 whole square, and we'll get this maximum intensity at points where cos delta will be equal to 1. Similarly, we'll have minimum intensity, that is I minimum, as under root I1 minus under root I2 whole square, and we'll get this minimum intensity at points where cos delta will be minus 1. Now we can calculate the ratio also, that is I maximum over I minimum, and this I maximum over I minimum will be root I1 plus root I2 in numerator, and in denominator we have root I1 minus root I2, and this whole expression is raised to the power 2. We can also write in terms of amplitude. Now we know that intensity is proportional to square of amplitude, so we can write the ratio of maximum intensity to minimum intensity as A1 plus A2 over A1 minus A2 whole expression raised to the power 2. Now if I say small r is the ratio of amplitude of the interfering waves, we can write the ratio of maximum to minimum intensity in terms of this small r. So this ratio will be r plus 1 divided by r minus 1 raised to the power 2, and this ratio of amplitude, that is A1 over A2, will be simply a ratio of intensity in under root. The second point that we have to consider, as we said in the beginning, the phenomenon of interference is based on conservation of energy. Now there is no destruction of energy in the interference phenomenon. The energy which apparently disappears at minima also actually is transferred to the maxima, where intensity is greater than the intensity produced by two beams separately. Now if we just calculate the average value over one cycle of variation works out to be 0. This is shown on the screen, where we have done the calculation of average intensity, and here delta is the phase difference between the arriving waves, and we know that the value of cos delta over one cycle is 0. Now as the average value of intensity is equal to sum of individual intensities, therefore energy is not destroyed, merely redistributed in the interference region. Now this point we must appreciate, mainly as there is redistribution of energy in interference. At the points of minima the energy depletes, and at the points of maxima energy spikes up. Now if we just calculate the average intensity is working out to be I average is equal to I1 plus I2. Now in case of interference, the intensity at any point is given by I is equal to I1 plus I2 plus twice under root I1 I2 cos delta. Now the third term in the expression for resultant intensity has an average value 0, as it is shown on the screen. So we come to the conclusion there is no destruction of energy, it is simply a redistribution. Now in interference all maxima are equally spaced and equally bright. This is a very important point. All maxima are equally spaced and equally bright. This is true for minima as well. All minima are equally spaced and they have equal intensity. Interference maxima and minima, they are shown on the screen. The distribution is also shown, and here we see the maximum value is again under root I1 plus under root I2 whole square, and similarly I minimum is under root I1 minus under root I2 whole square, and the average value is I1 plus I2.